right, it's one. So I'm going to thank everybody for joining us, and I'm going to thank you, Jason, for putting this on, and Kevin for hosting. And we will get rolling, and I'm sure people will join us as time is getting started. But thank you again, and happy to have you all here.
So we have a smaller group. It probably grow in size, but if you have questions, just feel free to put them in the chat or just reach out, raise your hand and ask them. I'm just going to introduce Jason here. I'm Kevin Cooper, everyone. I'm one of the co-PIs on Create, and my home institution is Indian River State College. I'm also the PI of the National Electric Vehicle Consortium, where we just bring together a critical mass of educators to tackle like standardization, certification, and issues across the industry. But today is about Jason and what he's done. And we'll go through my couple slides and then introduce Jason. So the first slide is createenergy.org. And it has tons and tons of resources, and Gabby's done a fantastic job on everything there. So if you need anything or want to look at our future events, go there. Gabby, next. Here's a list of upcoming workshops. They fill up fairly quickly, and they're really good workshops to embed like labs in your class, to get equipment grants, to do a lot of things. So I'd recommend, if you're interested in any of those, sign up quickly. And Gabby's put together and the team's put together a really good spring webinar series that you have here. All of it also can be found on the createenergy.org website. And this is where I was jumping to, because this is the most important part. And I'm not going to read his full formal background. What you need to know is he is one of the good people here who's done high school or teaching education the last 12 years at Aiden Middle School. And he's just goes out of his way. That's a science Olympiad coach. He's won some awards. He's got in fellowship program, leadership programs. And outside the classroom, ironically, we were just talking about fishing, and he has a wife and 2 kids. But I think back, and Jason, I want to thank you for what you do. I think back to my biggest influence was my early high school teacher. My 9th grade physics teacher steered my entire career. So just know that you're steering the career of so many people. And the more I learn, and I have 3 kids, the more I learn the formidable years of middle year school and high school, which steers their entire life. So the fact that you do it, kudos to you and to everyone else in the call that does it. So Jason, I'll turn it over to you.
Thank you for the introduction, Kevin. We're going to jump right in, if that's okay with everybody. I'm going to share the slideshow that I've created. And like I said, we'll jump right in. Let's see if I can do this.
So Jason, there should be a green button at the bottom of your screen, the share screen, and you should have access as a co-host.
All right, I'm trying to do it right now. Let's see. I got you. How about that?
There we go.
Okay, let's go. Let's see. Sorry. Is this a full screen for everybody?
Yep, it's good.
Okay. So basically what we're going to do is we're going to just kind of talk about the inspiration behind the project, how we blended the electric and solar power into a single challenge, the process that we went through of designing and testing the vehicles, and some real world connections that we had with career connections with the clean energy and engineering. So in the bottom of the screen there, you see that's kind of a finished product of one of our solar cars. So let's go. So like I just said, so the task was to design a vehicle that can maximize both speed and power while switching between energy sources. With the growing prominence of electric vehicle production across the United States, I wanted to make a project or create a project that would be that would be relevant for the students while also introducing them to the solar component, solar energy. So instead of teaching like solar individually and electric individually, I challenged them to come up with a vehicle that could seamlessly transition from solar to electric just with a push of a button. So the challenge was to create buy-in. So what I did was I reached out to I created first thing I did was I created a fictional company that was going to move to the area that specialized in creating these types of cars, the solar electric cars. And then I reached out to a colleague of mine who was a Keenan fellow with me, and I asked her if she would pose as the head of research and development for this Sun Charge Motors that was coming to Greenville. And I used ChatGPT to write her a script and everything. So I sent her the script, and she created this video. And this is how I launched everything off for the students. And I'll share this video with you.
I think you might have to share a different window to share the video. Like you go into the same share and you.
Okay, let me say that one more time.
I think you have to share the other window as well. Like
I
hit the
got you.
share-
Okay.
Yeah.
I got you. All right, let's see. I'm sorry. I don't zoom a lot if you can't tell. Okay. All right, here we go.
Unfortunately, we all Zoom a lot. So
I never do it. All right, let's go back. Here we go. All right, let me start over. All right, so this is my colleague, and she's posing as the R&D for Sun Charge Motors.
Good morning. My name is Wayanda, and I am the head of the Research and Development Department here at Sun Charge Motors. Sun Charge Motors is a new company that's coming to your area, and we specialize in hybrid solar and electric vehicles. I am reaching out to you today to see if you'll be interested to help us design and test prototype hybrid solar and electric cars, to help our R&D department find the best gear ratio that can maximize both speed and power. Good luck with your designs, and I look forward to hearing your results.
Okay, so let me go back to, sorry, I don't seamlessly transition from from one to the other.
You're doing a good job, dude.
Okay. All right, so after that, obviously we got 100% buy-in. The kids, they actually thought that they were doing work for a company. And this is one of the best as far as 100% participation that I've ever had with a group of students. And it was it wasn't a big class. It was probably 12 to 14 students in there. But we broke the project down into hands-on learning portions. So most of the students, if not all of the students, had never done anything with like electrical work. So that's kind of where we started. So before they could dive into designing the vehicles, they needed the foundational skills in electrical wiring and soldering. So what I did was I developed a certification process with a punch list of basic tasks that they had to perform and get my initials on before they could move on to the next task. So once they mastered these skills, then they were cleared to begin construction on their solar electric cars. So you can see there in the picture, there's a girl, she's got her gear fonts just out on her desk, and we're working on just putting the wires onto the motor. Let's go to the next one. All right, so this is the kind of the punch list we had. And it's just basic skills to start with. I mean, kids had never cut wire with wire cutters. They'd never stripped wire before. So each of these basic tasks they had to go through and perform in order. And this didn't take very long. They did these pretty quickly, but you can kind of see what we did. And if anybody's interested in this, at the end of the slide, at the end of the presentation, my email will be up, and you can just email me, and I'll just send you this stuff. So again, these are all the punch lists that they had to do. We'll go to the next slide. So after that, they had to learn how to wire and circuit a series and circuit. So this is just a crude drawing that just directions, a crude drawing I put up there. Basically showed what they needed to do as far as wiring the switch into the motor and the battery pack, just wiring in a series. So they did this. And pictures that each team designed a vehicle that could run on battery power but switch to solar when needed. So you can see there they're just soldering the wires that was the schematic in the previous picture. So the basic project breakdown, the students learned the basic skills, electric circuit soldering. They learned which gear ratios were best as far as maximizing speed. They learned how to switch from battery power to solar. So this is a vehicle. You can see they went in and modified the body a little bit to decrease the overall weight of the body. That's one without the solar panel on. And if you can see, one thing that we did, and I do this with my competition teams whenever we do solar cars, the piece in the middle is a ball and socket joint. Let me go back, see if you can see it. You can't really see right there. So it's a ball and socket joint. And whenever we're running solar in competitions, you never know how they're going to set up the track. You never know what direction the sun is going to be. So I like to have the ball and socket so they can adjust the solar panel to get full sun. So this is one thing that we did with this group as well. So we actually 3D printed ball and sockets. So the testing portion, after they had the cars built, we weighed our car, we wrote down the drive and driven gear sizes, and we timed speeds over 20 feet for both electrical and solar to see miles per hour. This is just an example. This is outside. They don't go very fast with solar, but they go much faster with electric. All right, so this is the final data collection that they had to do, and they had to fill this out and turn this back into me, and this was a portion of their grade. So this was the biggest thing that I wanted to do with the project, because I wanted to show the kids that you don't have to go to a four-year university to be successful anymore. And these are connections. Like if kids, what I wanted the kids to understand is if they really loved like soldering, they could go and do a career path at the high school where they could go into welding and then go to welding at the local community college. And look, they could start out making more money than I make now. Same thing with electrical, HVAC, solar energy, all that stuff those are careers where if you take the necessary classes and get on the necessary path in high school, you can go right into college and you'll be done in a few years making a nice living. So the materials, if you have any questions about the materials, all the materials that I purchased for my class and every single thing I do, I purchased from Pitsco Education. And the web address is right there at www.pitsco.com. They're in Pittsburgh, Kansas. So they have it's called Junior Solar Sprint kits. So everything you need is in the kit. All you would need is like the soldering iron and the wires and stuff, and you would need to purchase switches. But basic solar cars comes in that type of kit. But there's my email at the bottom, and I'll come back to the regular screen, and then if anybody has any questions, we can just kind of go through. So are we back?
We're good.
Okay.
You did a great job, man.
That was kind of short, I know, but I don't know if anybody has any questions about anything. I would be more than willing to just answer any questions you have.
What
Like I
class
said, so go ahead.
What classes do you teach and where did you fit this in? Like
I
from,
teach 6th, 7th, and 8th grade STEM.
okay.
So I did this in my 8th grade STEM class because I wanted to have this right before they were going to go to high school, so they could kind of make some connections with, you know what, I really like this. I could take some of these classes at the high school. So
And
that's why I
what is
decided to do it in the 8th grade.
awesome? And like, how long was the, like 2 weeks, 1 day, 1 month? I wouldn't,
The unit lasted about 2 weeks.
okay.
Yeah.
I think it's cool, man. And then, what was the ballpark for a price for the whole thing? What I love about it is it looks cheap so that like schools with limited budgets could do this, not, you
It's
know.
Yeah, it's not very expensive. I don't have the exact price in front of me, but if you went to let me see if I can pull it up real quick. Pitsco.com.
Yeah, I can go there.
Yeah. If you go to Pitsco.com and yeah, there you go. Solar. Yeah, thank you, Matt. Solar Ray Catcher Vehicle Kit, like everything is right there, and you could do a class pack, or you can just do if you're only doing a certain amount, you could buy what you need. The only thing that you would need to purchase outside of, and I'm not sure if Pitsco has them, they probably do, are the switches.
Gotcha.
So I just went to Lowe's and picked up some switches for them to solder into the electric vehicle.
But you're real right. I don't have the classroom experience, but working with both of my kids, like stripping a wire and even like we try to make MC4 connectors and like putting on
Yeah.
the end of it's a talent that you have to learn actually. You know, it's not like,
Well, the longer I've taught, the more I found out that the kids that know how to work with their hands it's getting less and less every year. I mean, the kids, they can do everything they need to on a phone or a computer, but I mean, doing the hands-on stuff is kind of getting obsolete.
yeah, if you go back in time, like cars are not meant to be worked on anymore. If you look at a modern day car, it's not meant to work on, right? Like you have to go
Right.
back to like all the people that used to work on cars or the home television, it's all throwaway now. So like
Right.
people don't get the skills at home anymore because no one's working on it.
Yep.
So, but I'm
Part of
dominating.
it too is, some of us are old enough to remember growing up where you had a Heathkit, electronics board that you could build your own radio and strip your own wires and stuff like that. And
Yep.
kids don't have that anymore. They have
No.
video games now,
Yeah. But the kids actually love doing stuff like this. If you talk to them about the danger of the soldering iron, when you tell them it's 750 degrees, I don't know if they really believe you. But stuff like that that makes them interested in using it. But like I said, it was a great project that I've never done a project where all the students were just 100% like locked. They were locked in.
That's how many
I
kids
guarantee if anybody dropped a little bit of liquid solder on their fingertip, they'll remember that for a long time.
They will. And look, I've told them that before. I said, look, this solder right here, if it falls on your pants, it will burn a hole in your pants. So yeah, I talked to them about that. They were careful. Nobody burnt themselves. So
I'll open it up to other questions from the group or I'll call on people.
Jason, I typed this in the chat too, but I was just kind of observing it. It looked like the car runs on like 2 1.5 volt batteries, and that the solar panel you had was like 6 cells for a similar 3 volt output. Is that right?
yeah, it was. They just ran on 2 AA's.
Okay.
2 AA's, and we just ran them. So we wired. We just did. I think we did alligator clips from the solar panel. So
And did you have to have like a totally clear sky day at noon, or did it work at different times of the day, or partially cloudy, or?
In order to get maximum speed, you need 100% sunlight. That's the only downfall with those types of solar panels. So it's tough to run. You gotta play it right as far as getting outside and running in full sun.
You can make it a challenge where they have to run along with a really strong flashlight.
Yeah. Yeah, that hardly works when you.
Doesn't work. Yeah.
I've tried it. I've tried it with a lamp before, and it doesn't work. But
Yeah, we
they're
were
pretty
trying to
fast
do
on
some
they're pretty
experiments,
fast on
but
the battery. So I'm sorry. Go
it,
ahead.
the only artificial light source we've found is like a high intensity stadium light for what like you use for nighttime baseball games or soccer
Yes.
fields or
Yeah.
something like that.
Yeah. Yeah.
How many per student would you say? How many students per car? If people wanted to
In
replicate.
my experience with all group projects that I've done throughout my teaching career, more than 2 is too many. 3, you get somebody that just kind of stands around. When you've got 2 people, you can kind of delegate the work. And that's the way it was with me. I had a couple of people in that class that, you know what, I want to work by myself, and I didn't. I mean, I had enough materials, and I let them. But I wouldn't do more than two people in a group.
My daughter just literally told me 2 days ago, in every trio, there's a duo.
Yes,
Yes.
100%.
Yeah.
Yeah. And if that class would have been really, really small, I would have done individual.
Yep.
That way you get to experience the whole part of the project.
Jason,
Yeah.
I'm curious about the Pittsco kits. I've played around with a couple different solar car kits, and some of them you're good for like 1 or 2 runs, and then they crash, and immediately the axle breaks, and you're done.
Yeah.
How robust were the Pittsco kits?
They're pretty robust. I mean, what you have to do, so when you're running these outside or inside, you have to run them on fishing line. So you're going to put screw eyes, and this comes with the kit, I believe. You have to put screw eyes, or if you don't have screw eyes, what you can do, and we do this at competition because it's easier to get the cars on and off the fishing line. We'll cut a paper clip and just poke it through the bottom of the car, and that way you can just slide the car over the fishing line and run them that way. But if you don't run them on fishing line, they're not going to go completely straight. So, and I have the kids go out in the hallway or go outside and test their cars not on fishing line, and I tell them beforehand. I said, look, when you run this, you need to get somebody, your partner, down the hallway to catch this car, because if it hits the wall, the axles are going to fall off, the motor is going to fall off, because they hot glue everything onto the body, and the body's made out of, it's just a balsa wood sheet.
Okay.
So they just hot glue everything or super glue everything to it, and if it hits the wall hard enough, then everything falls off. The only problem I found is if you're a little heavy-handed with the servo motors, the little the ports on them will break off. That's the only problem I've had with the motors. But I can't complain about Pittsco stuff. I mean, I'll talk about them all day.
Any of their other equipment that you'd recommend for folks that are teaching in?
So with STEM, let's see. I mean, I do CO2 dragsters. In 8th grade, I get all my stuff from them, and just like with the Junior Solar Sprint Ray Catcher, it's called Ray Catcher Solar Kit. The CO2 carts come in a box, so you can order a whole class pack or however many you need. Everything comes in the box. So, yeah, I mean, a lot of stuff that I use. So with STEM, we use they're called expeditions. We do STEM expeditions through Pittsco. That's their kind of their curriculum, and so that's what I teach in 6th, 7th, and 8th grade.
Yeah, I have fond memories of my 7th grade CO2 car. It was wicked fast for one run, and then it snapped in half at the end of the track.
We actually did them. We did them today in my regular 8th grade class, and we had 14 cars, so we did a bracket format, and I seeded them based on weight. And there was one car, he got the number 2 overall seed, and I told everybody in the class, I said, you need to be careful with this guy because his car was so thin. I said, I think he's going to get disqualified because when his car gets to the end, I think it's going to hit the towel and snap in half. And sure enough, first run broke in half, so he was disqualified first run.
It's a great learning lesson, though. I mean,
Oh yeah, I know. We talked
Yes,
because we
yeah.
talked about mass is the overwhelming factor as far as if you can get your mass on your car as low as possible, then you're going to win. And that's what happened. Whoever had the lowest mass, but not the thinnest, that he ended up winning today. So they really worked on trying to get them as low as possible, without being too fragile, I guess. But we do bridges. I order Pittsco has a bridge pack. We get they're 1/8 by 1/8 balsa sticks. We build structures with the balsa wood. So we got bridge testers from Pittsco. I mean, there's so many hands-on things that you could do with them. They do.
So I have a side question. So do you
Yes.
have a lot of success sending your students to community colleges, or do a lot of them wind up going engineering routes or science routes?
A lot of them do, and I hate to say this, but like a lot of the kids, I try to steer away from 4-year colleges. I
Mhm.
mean, I know some of the kids I talked to a few years back, they're now going into college, and I told them, I said, look, if I had it all to do over again, I would probably go to community college and either do HVAC or welding. And a lot of kids that I taught in STEM are doing welding. And I said, look, and do this. If you go to do welding, get your scuba diving license and do underwater welding. You're going to make a lot of money. And I think some kids are actually going to be doing that too. So they're actually listening to me. Some of them are.
Yeah, that's a specialized skill set there.
Yep.
That's interesting. So one of the guys on my team, Ken, you know him well, Nick, does some underwater welding. So
Yeah, yeah.
But they have solar, I mean not solar, but wind power kits at Pittsco, and they've got a 200 or 300 page catalog just full of activities and lessons, and it's a great resource I use.
I'm curious, for the cars, are you just using regular like alkaline AA batteries, or have you
Yes.
tried using rechargeables with them at all? And
I
maybe
have not tried using rechargeables. I mean, I need to do that because you have no idea how much money I spend in batteries every year.
Yeah, you can now buy, AA lithium ion batteries that actually have really, really long lifetimes and,
Yeah.
and pretty consistent discharge from state of full charge all the way down to 0% capacity.
Yeah,
Give
I need to
you
look.
a really consistent current.
Yeah, I need to look into that because, like I said, I mean, we go through a ton of batteries. So,
all right, I am going to turn it back. I think any other questions? I didn't know if Gabby had final thoughts, and I didn't want to
No,
upset.
I think we've covered a lot of good ground, and thank you, Jason, for sharing with us today.
yeah, enjoyed it. Thank you.
Cool.
Well, stay in touch, Jason. Really cool
Yeah.
to work with you in the future. Would like
But
to bring my
yeah.
kids to school even. So,
If anybody has any questions, though, just my email, just send me an email and I'll send you like everything I have. I'll share the documents and everything if you're thinking about doing this lesson.
So looks like universally everyone loved it in the chat window, Jason, by the way.
Well, thanks, Jason, and have a good weekend.
All right, thank you. I appreciate it.
Bye, guys.
Thank you,
Bye.
everyone.
All right, thank you.